Good morning. Now we are going to be video for the problems which were asked in 2017 November. So now we have again already mentioned this. Go through this video which are in playlist of mechanics of structure, strength of materials. So you can refer these videos which are related with SFD and BMD. Now we have given this problem a simply supported beam loaded and supported as shown in figure. I will go a little bit fast now. So now we have this as VA, we have this as VB. And then we will take moment about B0 and we have VA into 6 minus 20 into, now this distance is 4 meter, this is 1 meter. So minus 20 into total we have 5 meters into 2.5 center, it will act at center which will be 20 into 5, and this distance we will have from this to this 2.5 meters. So we will have this into 3.5, and due to concentrated load 20, it will be 5, and that is equal to 0. And from this we will get value of VA, that is equal to 20 into 5 into 3.5 plus 20 into 5 divided by 6. So it comes 75 kilonewton. And then apply summation Fy0. Now this is 75 kilonewton. So we have 75 minus 20 minus 20 into 5 plus VB equal to 0. And from this we will get VB is equal to 45 kilonewton. So we have VA 75 and VB 45. Now we will go SFD. Now I will write fast over here. So shear force. So left of A we have 0. Right of A we have 75 kilonewtons. Then we have left of D 75 minus 20 into 1, it will be 55. Then right of D 55 minus 20, 35. Then at C 35 minus 20 into 4, so 45. Left of B same 45 and right of B 0. Right of B 0. And then we will plot it. So we have 75, then we have 55, then we have 35. Both values are at D, you can see over here. So these values, then at C 45 kilonewton, and then left of B again 45 kilonewtons, and right of B 0. So you can see we have x to the power 0 till C. So till C we have x to the power 1. Now here we have 20 kilonewton. Difference you can see, vertical ordinate is 20 kilonewton. And here vertical ordinate 75 and this is 45. Then we have bending moment. So now we have bending moment. Bending moment. We have at A 0. Then we have at D 75 into 1 minus 20 into 1 into 0.5. So it comes 10, so 65 kilonewton meter. Then at C, if I will calculate from a right side anti-clockwise plus, and therefore we have 45 into 1, so it comes 45 kilonewton meter. If you find from left side, then you have to write all, that is 75 into 5 minus 20 into 4 minus 20 into 5 into 2.5. And then we will have this value. So just I will calculate 75 into 5 minus 80 minus 20 into 5 into 2.5. So yes, it comes 45. And then we will plot it. So we have, this is parabola x to the power 2. Then again we have parabola x to the power 2. And this is linear line x to the power 1. So that I will explain over here. So we have x to the power 0 from A to C. So A to C we have x to the power 1. Here we do not have any load. So here x to the power 0. And this is x to the power 2. And then B to C, we have x to the power 1. So now we have another problem, that is we have to draw load diagram and BMD. So now we will start with, so we have two formulas I will not mention over here. So now we will give names to this. So we have actually A, B, C, and then D. So then we have at A, final shear force minus initial shear force. So 90 minus 0. So we have 90 kilonewton. So upward, so will be considered as reaction. Then we have between A to B, final shear force we have 70. Initial we have 90. Upon span is 2. So we have, this will be minus 10 kilonewton per meter. So it is downward. Now at B, we have final minus initial 10 minus 70. So minus 60 kilonewton. So it is downward. Then we have B to C. We have final shear force minus 10, initial minus 10, and span we have 2. So again it comes minus 10 kilonewton per meter. Then at C, we have final minus initial, final minus 70, initial minus of minus 10, and it will be minus 60 kilonewton, means again downward. And then between C to D, we have final minus initial, minus 90, minus of minus 70 upon 2, and it comes again minus 10 kilonewton per meter, means downward. And at D, we have final shear force 0, initial minus 90, it will be plus 90, so we have upward. So likewise, we have to draw loading diagram. Then we have bending moment diagram. So we have now bending moment at A0, then symmetrical. So bending moment at A and bending moment at C. Because as it is symmetrical with center, so we will have same bending moment. So we have 90 into 2 minus 10 into 2 into 1. So it will be 180 minus 20, 160 kilonewton meter. So we have, this will be 160 kilonewton meter. Then at center, so where we have shear force 0, so this will be 1 meter only. And then this point I will say, let us E point. So we have at E equal to 90 into 3 minus 10 into 3 into 1.5 minus 60 into 1. And we will have this value, that is 90 into 3 minus 10 into 3 into 1.5 minus 60, and it is 165 kilonewton meter. So we have center 165. This already we have calculated at C, and this is 0. So we have, this is bending moment diagram. So you can see over here in loading diagram we have x to the power 0 throughout. So you can see throughout we have x to the power 1, and throughout in BMD we have x to the power 2. So likewise we have to solve the problem that is of shear force and bending moment diagram. So now we will stop here only. Thank you.